Hello students, today we will be completing tutorial number 14. In this tutorial, we will begin using the sound sensor. The sound sensor detects the decibel level, the softness or loudness of a sound. Sound sensor readings are displayed in percentage of sound the sensor is capable of reading. Please note, the soft squishy material inside the sensor is quite delicate. Please do not touch the orange part of the sensor with your hands. The oils on your hand will clog the sensor and cause it to malfunction. Step 1, make sure you have the sound sensor built and attached to the side of your robot. Also needs to be plugged into port number 2. If needed, go to pages 24 to 26 of the Rembot building instructions, which are also on the Rembot website. Build and attach the sound sensor. Step 2, we will now make a program where our robot waits to hear a sound before moving forward. First, we will need to find the current threshold of sound in this room. To do this, turn on the NXT. Now press the left or right arrows until you reach the option View. Press the orange button to enter View mode. Press the orange button again to select Sound dB. This ensures that the sensor is reading the amount in decibels. Press the right arrow to move your selection to port 2 because that is where the sound sensor is plugged into your robot. Again, select the orange enter button to select it. Remember to stay quiet. Write down the lowest number you see on the screen. The number will bounce up and down as the sound in the room changes. So we'll pretend that we got 25. Actually, let's say 50. We'll make it really easy math. Let's say we get 50 as our quietest number. Next, clap and write down the highest number you see. This number should be a 100. If not, clap louder. Find the average of the two numbers. So 50 and 100. We're going to add that together to equal 150. Divided by 2, and that would make, in this example, 75, my threshold. This number is the threshold for this current environment and the halfway point for sound when you are quiet versus when you are loud. Anything less than 75 we'll consider a quiet sound. Everything that is louder than 75 will be considered a loud sound. Write down this threshold in your notes somewhere so you do not forget it. Step 3, now we can start making our program. First, we want to tell the robot to do nothing when the sound is quiet. So we will add a while block to tell the robot to do nothing when it is quiet. Step 4, next you need to alter the while block for our specific situation or environment. Since we are waiting for the sound sensor, make sure to set the variable to sound value or sensor value sound. Then we need to tell it to be quiet when it is less than our threshold, which we found in step 2. We said it was 75 for our example. Step 5, since the robot is not doing anything when it is quiet, we don't need to put anything inside the parenthesis of the while loop. But what if I'm afraid I'm going to forget what my robot should be doing? We can always add comments to our program to give ourselves reminders. While we can see them in the program, the robot ignores any of these statements. All comments appear green in the Robot C software. Note, if you wanted to skip a programming step which you had already programmed, you can always click the number next to the step to turn it into a comment. So if I click this, now it becomes a comment. I can click it again to uncomment. Let's add a new comment to our program and say robot does nothing, which we would consider an idle loop. It's sitting idling. This motion where the machine does nothing is called an idle loop to computer programmers. In my comment here, robot does nothing, which is an idle loop. Spelling technically doesn't matter here because it is a comment to you. The humans are the only ones reading this. The robot does not read these instructions. Step 6, next we will tell the robot to move forward 3 rotations when there is a sound. Since we're referring to motion that is more than the threshold, we will put these directions after the while loop. When someone claps or talks loudly to the robot, it will end the while loop and cause the robot to move on to this next set of instructions, which is step 4 here. Your program is now ready to download and test. For the practice, make sure you've completed the practice problem given throughout the tutorial. These skills are necessary to make your robot complete the task below. So your final project task, program your robot to wait until you clap to go backwards 5 rotations, Then have the robot turn 180 degrees to face the opposite direction. Since the robot is turning an exact amount, that means you will have to use the robot calculator and convert that into how much the tire is turning to make that happen accurately.